Alright guys, so we're taking a look now at making some explicit equations given some tables for arithmetic and geometric patterns. Okay, so with this one we are using those explicit equations, okay, not the recursive. So the explicit, remember, for arithmetic looks something like this: y equals a plus or minus b times x. And for geometric, y equals a times b to the x. Now you can write the arithmetic in slope-intercept format as well, but personally I prefer to write it because then we're kind of using the same convention and I can treat it the same way about the start and the growth, okay, as opposed to mixing up the letters and concepts. So the main idea here is that we notice the start number, right, where our input is 0, that's our start number, and then our growth as we go down, which in this example we're subtracting 4 each time. So I'd go y equals my start. What am I doing to it? I'm subtracting 4 times that by x. Okay, that's really all there is to it on this. Okay, is that you again find that 0 number and then you type in your output equals your start number, and then how is it growing? In this case we're adding 10, so plus 10, and then our x is always down below. Okay, so there's a few examples there. Also, let's take a look at a few more examples, and then we'll cut you guys loose to try the other ones, and then we'll go back and take a look. So if we look at number 10 here, we see that our 0 term is not up here. Okay, that doesn't make -2 you're starting. You always start at that y-intercept, at that 0 term. So I can go y equals my start. Then how is it growing? Well, -19 to -13 to -7 to -1. We're definitely adding 6. So we're adding 6 to that, and we're timesing by x because we're adding 6. For 11, we've got our start number, so y equals 1. Now what's our growth? Well, we are definitely timesing by 3 here, aren't we? Okay, so we times by 3. Now because it's multiplication, now our variable goes up top. So it's important to distinguish where the variable goes, because that makes a big difference. If it's multiplication or division, it goes up higher. If it's addition or subtraction, it goes down low, because repeated addition and subtraction, the shortcut is multiplication. Repeated multiplication and division, the shortcut are powers. Okay. We also have different formats, right? So we can do it in the, and I actually wrote that one wrong if I was doing it in that format, didn't I? Should have been n. So this is that sequence notation right here. So you can do that one if you want, but I'd get in the habit of doing it more like that, even though I've labeled them the way I have. Okay. Alright, so try these on your own, and then come back and take a look and see how we've done. Okay. Alrighty, so let's jump into these. So I'd go y equals my start, and my growth is adding 7, so plus 7 times x. My start is -28. My growth is minusing 6 times x. My start is 7. Our growth is adding 2, so I go y equals 7. What am I doing to 7? Adding 2 to it. So that's my growth, times it by x. Y equals -11 for my start, and my growth is subtracting 5, so minus 5x. Okay, so not too bad, isn't it? So start of -33, growth of minusing 3, so minus 3x. Start of positive 27, growth of adding 8, so plus 8x. Start not of 40, start of 36, and I am subtracting 4 each time, so minus 4x. So again, where am I starting? Starting at 9. What am I doing to 9? Well, as we go down our table, we are adding 4, so plus 4 times x. Alright? Okay, so those back ones might be a little more complex because now we shift to the geometric. But again, and this is why I like doing it, if we go up here, why I like doing it this way as opposed to this, because then, regardless if I didn't know that this was geometric, I still say, oh, I start at -2, just like I normally do. Then I wait till I see the growth, in this case timesing by 5. Then I recognize, oh, okay, now I have to treat this one different than these guys, because the only other difference is I put a multiply there and times, or to the x power. Okay? So starting at 3. 3 to 12 is 4. Positive to negative is -4. So times -4 to the x. Again, I could write it in function notation, just my output, right? We start at -1/6. What am I doing? I'm timesing by 6. So times 6 to the n. It's the same thing, but I would just get in the habit of doing it like this. Now my zero's in a different position, but that doesn't matter because I treat it the same way. Now, when we get to division, okay, yes, I can just go y equals 108, and we're dividing by 3. Repeated division, so I'd put it to the x, and that would work just fine. Okay, or I could have even, like on number 18, I could even say starting at 1, dividing by 2 each time, so 2 to the x. Okay, and those would work. Mathematically, they work. However, we don't generally write them that way. Okay, so instead, when we're doing division, what we really want to do is we would rather write it, instead of dividing by 2, say timesing by its reciprocal, so timesing 1/2. So instead, I'd go y equals 1 times 1/2 to the x. Instead of dividing by 3, I'd write y equals 108 timesing by 1/3 to the x, that reciprocal, right? So here, instead of dividing by 5, we think I'm actually timesing by 1/5. So I'd go y equals my 0, 125, times 1/5 to the x. Okay, and I would get into that habit of writing it so that you're more aware and used to it, so when you see it. Okay? Alright guys, so there we go with our tables. We are now done.